So what can we do with binary numbers? Well, one thing we can do is addition. So just like with decimal numbers, we can perform addition of binary numbers. So let's first do an example with decimal because we've done that a lot. So we have some number here, 37, 34 plus 51, 68, and we're going to add them together. 4 plus 8 is 12. Well, 12 doesn't fit in a single decimal digit. So we're going to take the least significant digit, 2, and put that in our sum and carry out that most significant digit because it really belongs in the tens column anyway. So we carry it over to the next column and we get 6 plus 3 is 9 plus 1 is 10. Again, carry out that most significant digit of that result. And we get 7 plus 1, 8 plus 1 is 9. 3 plus 5 is 8. And we get our result. And so we have carries here. This 1 carried out from this least significant column, or the 0th column. It carried out to the next column, the first column. This 1 was the carry out of this column, column 1, and carried in to column 2. And in binary, we have the same thing. So we have this value here, 1011, a binary number, 0011, and we can add those together. We get 1 plus 1 is 2. Well, 2 in binary is that doesn't fit in a single bit or binary digit. So we take our least significant bit of the result of that sum and put it in our sum here, and then we carry out that most significant bit to the next column. Now we get 1 plus 1 plus 1, well, that's 3. So 3 in binary is that. So we take, again, our least significant bit of that result, put it in the sum, and then we carry out that most significant bit. Now we get 1 plus 0 plus 0, that's 1, and 1 plus 0, also 1. And we can double check, right? This number here is 1 plus 2, 3 plus 8 is 11, plus 3, we expect to get 14. Yep, that's what we got. We can double check that we didn't make a math error in that way. So let's do some examples and add the following 4-bit binary numbers. So pause your video right now and try these sums out. Okay, so now after you've tried it on your own, let's do it together. So 1 plus 1 is 2, which is 0, carry the 1. 1 plus 0 plus 0 is 1. 0 plus 1 is 1. And 1 plus 0 is 1. And so we got 9. I'm converting these to decimal. 9 plus 5. In other words, 1 plus 8 is 9. 1 plus 4 is 5. We expect to get 14. Check. We got it. No math errors. Okay, and let's try the next one. I'm going to write it over here to give a little more space. 0, 1, 1, 0. Add these together. We get 1 plus 0 is 1. 1 plus 1 is 2. So 0 carry the 1. 1 plus 0 plus 1 is 2. 0 carry the 1. And 1 plus 1 plus 0 is also 2. So we get 0 carry the 1. Okay, and this brings up a very important point about results. If we have we have fixed bit widths. So we're dealing with 4-bit binary numbers. And so we are adding 4-bit binary numbers. The result is also 4 bits. 4-bit addition, 4-bit result. 4-bit operands here, we get a 4-bit result. So actually the result of this is 1. So we added two numbers that are clearly greater than 1 and got the result of 1. So what's going on here? Well, what happened is overflow. So this result does not fit in a 4-bit value. And we can double check that and say, okay, well, what are these numbers? Well, let's see, we have 1 plus 2 is 3 plus 8, so we have 11, and we're trying to add, so no 1, we have a 2 and a 4. We're trying to add 6. So the value we'd like to get is 17, but what we got instead is 0001. Because we're only dealing with 4-bit values. Super important, 4-bit addition, results in a 4-bit, or 4-bit operands, we get a 4-bit result. And so what happened is we overflowed that range. 17 does not fit in a 4-bit value. The largest number we can fit in a 4-bit value is what? 2 to the n minus 1, or 2 to the 4 minus 1, or in other words, 15. And 17 does not fit in a 4-bit value. So to recap, digital systems operate on a fixed number of bits. So when a result is too big to fit in that fixed bit width, then we get overflow.